Electronics for all. Hello everyone. In this tutorial video, we will explain and design a darkness detector sensor that can use in many applications, or use with any 220 voltage devices, or just as a darkness alarm. Darkness detector is simply a LDR, light-dependent resistor interface square wave generator. In this project, the square wave generator is developed as a 555 timer IC based a stable multi-vibrator. As this circuit is primarily based on the working principle of LDR, before going any further to understand this LDR circuit, we must get the basic details of the LDR. The figure shows an image of various types of LDR. The circuit should seem very similar to the astable multivibrator. That is because the circuit is a astable multivibrator with only one modification. This modification is done at reset pin 4. In a normal astable vibrator, this pin is connected to +9 volt, but since in this case we are supposed to generate a pulse on the condition of absence of light, it is not connected directly to +9 volt. The resistor network provided at the reset pin provides a virtual ground so to keep resetting the IC, and so the square wave output is stopped in the presence of light. The transistor here drives the relay because the relay driven by IC is not a good idea. The purpose of a diode connected in parallel to a relay coil is to avoid damaging some nearby components sensitive to high voltage. This voltage is generated in the coil when the current flow is interrupted. The purpose of the diode is to allow the current flowing through the coil to continue circulating when the relay is deactivated. The relay here can be replaced with LEDs to create an output response of lighting, or replaced with a speaker to work as a darkness alarm. So once the LEDs are placed and the darkness falls, we will have an emergency backup light. The transistor here need not be a PNP compulsory, but one can replace it with a NPN, and the pin connections should be connected accordingly. Before going to explanation, the circuit should be assumed on and is off in the presence of light. This condition is off in the presence of light can be achieved by adjusting the 1 mega ohm trim pot. Now in the circuit one can observe a voltage divider with 1 mega ohm, 100 kilo ohm on one side and LDR on the other. The reset pin is connected in the middle. The trimmer pot is said to be adjusted because to create enough resistance on the top branch of voltage divider to drop almost all the potential +9 volt in the top branch itself. This leaves a virtual ground at the middle of divider, reset pin. Since the reset pin of 555 is a low level triggered, the timer IC will be reset mode continuously, and so there will be no square wave output as it should be. From this we can conclude that in the presence of light the 555 IC will be in complete reset and provides no output. Now when the darkness falls on the LDR, the resistance of the LDR increases drastically as explained in introduction. This increase of resistance in the second branch, one with LDR of voltage divider, will be enough to change the ratio of voltage sharing between the two branches of voltage divider section. Once this happen, the potential at the junction of voltage divider circuit rises from 0 volt to 2 volt approximately. And similarly the voltage at the reset pin rises. This rise of voltage will be enough to lift the 555 IC from reset mode. Once this reset mode is lifted, the timer generates square wave output. So it is concluded that once the darkness falls on the LDR, the square wave output is generated by the timer. The square wave generated by the timer is fed to the PNP transistor to drive the relay. Even after adjusting the trim pot, the buzzing do not stop. The LDR might have enough resistance to put a potential at the reset pin. Put another 100 kilo ohm resistor in series with 1 mega ohm potential. Check if the reset pin 4 is accidentally connected to +9 volt rail in any way. There is no buzzing even in the dark. LDR might not be developing enough potential at the reset pin. Put a potential in series with LDR and adjust it to get buzzing. If the transistor is getting hot, drive the signal of 555 troughs the 100 ohm resistor to the base of transistor. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.